Hi everybody, welcome to Algebra 2. This is going to be section 4.8, and what we're going to be looking at here is what's called remainder theorem and then factor theorem. This is going to be taking concepts you've learned before and again just applying them to these theorems. So the first question here says, finding zeros of a polynomial function written in factored form. So I have a note here in red for you, and it says set each part that has an x, a variable x, equal to 0 and solve for x. So again, this is something we all have done before, but let's go ahead and see it again in practice. So I'm going to take each part that has an x, and I'm going to set it equal to 0. So I have this part right here, there's an x there. So I'm going to have x minus 6 equals 0. And then I have a part right here that has an x. So I'm going to set that equal to 0. X squared minus 36 equals 0. And then I have this part right here that has an x, and I'm going to go ahead and set that equal to 0. And then we just solve. So let's go ahead and solve each one. We need to add 6 to both sides here. I'm left with x equals positive 6. We need to add 36 to both sides here. And then we'll have x squared equals 36. But remember, we're not done yet. We need to get rid of that exponent of 2. In order to do that, what we need to do is take the square root of both sides of the equation, and that will get rid of that exponent. So I'm left with x equals 6, but not just 6, it's also negative 6. Remember, if you put 36 or the square root of 36 in your calculator, you will get the answer of 6. But remember, 6 squared equals 36, but so does negative 6 squared is 36. So we're going to have both. Over here, we're going to minus 6 from both sides, and we're left with x equals negative 6. So my solution is x equals 6 comma negative 6. If you notice, the variable of x only represents two different numbers. What I mean by that is there's a 6 here and there's a 6 here. I'm not going to write two 6's down. It's just saying that x represents 6. And then same thing over here on the right hand side. I have negative 6 and negative 6. So negative 6 would represent x as well. So because I only have, I guess, two values, I will only have two values here to represent my variable of x. Go ahead and try the one on the right on your own, and we will cover it in class. If you're lost or confused, again, we'll cover it in class. So now we're going to get into what's called remainder theorem, and we have a definition here for remainder theorem. It says, if a polynomial p of x is divided by x minus n, then the remainder is p sub n. Or excuse me, not p sub n, but p of n. And then what is the remainder here in regards to remainder theorem? The remainder is the solution of p of n. Okay. Now, a lot of times when we see these in word sentences, we have no clue what it means. Sometimes it helps just to see it in practice and see how it's done. But moving into number 2 here, it says, using the remainder theorem to evaluate a polynomial. Specifically, give the quotient and the remainder for the associated division and the value of p of c. To do this, there are 3 ways to evaluate p of c, meaning c is just going to be a value. Okay, they're going to give you that usually. The ways that we can do this are all highlighted in yellow, green, and orange. One way is do substitution, which you've done. The other way is to do synthetic division, which you did early on in this chapter. And then the third and final way is to do long division here, which again you did in this chapter. What it says here is, in this case, synthetic or long division is most efficient because it asks for the associated quotient as well. So that's kind of the value that you're going to get out of synthetic and long division is that it's going to give you your quotient along with your remainder, whereas substitution is not going to give you your quotient. So for this, we have our quote-unquote P of C right here, so -3. If you were to do substitution method, you would need to plug -3 in for all your x values. But we're not going to do that. We're going to do synthetic division. So I know what my c represents. It is -3. It tells me so. And then we need to set up kind of our L-shaped box here, or half of a box. And then I have my coefficients listed above, and I notice my exponents go 3, 2, 1, and then 0. Perfect. So let's put our 2, our 4, our -4, and then lastly, another -4. Now the first step in synthetic division, is we're going to bring down that 2. So we're going to bring down that 2. Now what I need to do is I need to multiply the -3 and the 2 together. And what that will give me is -6. Now vertically what I need to do is I need to, and hopefully I can help you by doing this, I'm going to put in a plus sign. 4 plus -6 gives me -2. Now what I'm going to do is I'm going to take -2 and I'm going to times it by -3. So -3 times -2, that gives me a +6. I'm going to add -4 plus 6, that gives me a +2. 2 times -3, that gives me -6. -4 plus -6 gives me a -10. Oops. Now that I have that, what I'm going to have down here is, remember, when we're doing synthetic division, in a simplest form, our leading degree from our leading term is going to drop off. So here I have x to the 3rd power, but down here I'm going to have x squared. And then it goes x to the 1st power, and then we can call this our c, and then our -10 is going to be our remainder. So let's fill in our answer down here at the bottom. Our quotient, again, is what we have down here, right here where I'm circling. So that's going to be 2x squared minus 2x plus 2. And that's why we labeled it our c. If you remember, this was our a, this is our b, and this is our c. And then our remainder is what is over here on the far right-hand side. That's our -10. So if you remember, whatever let me go to the definition up here at the top. It says if the polynomial p of x is divided by x minus n, and that's technically what we're doing right here. We're dividing it by x minus n. Then the remainder is p of n. So the remainder is the solution of p of n. So if this is p of n or p of c, well, then we just take our remainder and it's going to be -10. And that's how you do it. Now, I always say if you don't understand a lot of like the word sentences, then at least know the mathematical skills and the procedures that you need to do in order to solve the problem and answer the questions that are being asked. Go ahead and try the one on the right-hand side, and we'll cover it in class. Okay, now we're getting into factor theorem. So before we looked at remainder theorem, now we're going to look at factor theorem. So what factor theorem says is if polynomial f of x has a factor, x minus n, which is what we see right here where I'm circling, which so did, if you looked at the other one, so did the remainder theorem. X minus n if and only if p of n equals 0. So basically we're going to want our solution to be 0, and if it is 0, then we know that it is a factor. So note, if we substitute n for x and get 0, x minus n is a factor, so that's what I just stated, but make sure that you have that in your notes. I've noticed a lot of not adding my little notes in there, but it will be helpful for you as you're using your notes for your practice quizzes or your homework, things like that. So factor theorem, specifically evaluate p at the proper value, then determine if the given expression is a factor. So we're basically just going to find out our answers and say it is a factor or it is not a factor. Now, doing factor theorem, you can use kind of two methods. You can use substitution or synthetic division. It's up to you. I'm going to do both, and you can find out what's probably easier for you. So I'm going to do substitution right here. So substitution. So now that we have substitution here, I have my x plus or minus my n, and then is a factor of, and then we have our expression right here. Okay. So I'm looking at this x plus 2. We want to find the value of x, so technically you're setting it equal to 0, right? Let me put this here. If I have x plus 2 here, and I'm doing substitution, I want to find what x equals. So you first have to set it to 0, minus 2 to both sides, and you get x equals 2. Again, 2 represents my, negative 2. Negative 2 represents what my x is. And again, I need that so that I could plug my x value, which is negative 2, in for all my x's, and that will be substitution method. So what we have is p of negative 2 equals negative 2 to the 4th power plus 2 negative 2 to the 3rd power minus 3 times negative 2 minus 6. If you were to do negative 2 to the 4th power, you're going to get 16. And then we have negative 2 cubed, which is going to be negative 8. So let's just kind of break all this out so we don't make any mistakes. Negative 8 plus 6, and then minus 6. Then we get 16. 2 times 8 is negative 16, plus 6, minus 6. So what do we get here? And through our substitution method, we get 0. We get 0. So if we have p of x, and our x represents negative 2, we're going to put that right there. Our p of x, again, x value is negative 2. Well, we're saying that if we substitute our x for negative 2, I'm going to get a solution of 0. Down here, right below it, it says circle 1. X plus 2 is or is not a factor of p of x. Well, again, up here at the top, our note that is so vital that you have this in your notes, it says if we substitute n for x and get 0, x minus n is a factor. Again, we took our n, we substituted it in for x, and we did get 0. So x plus 2 is a factor. Now, we can, that's weird that it did that. We can also use synthetic division, and some people might find this easier and a lot quicker. So I want to do synthetic division up here. Okay, so let's set it up. Again, my x value is negative 2. I'm going to set up my half box, my L shape. And then we have x to the 4th power. Well, that's a 1 in front of the x. And then it goes a 2. And remember, it goes 4, 3, and then 1. So I'm missing my 2 here. My x to the power of 2 should be in there. So I have to replace it with a 0 or fill it in with a 0. And then we have our 1, which is negative 3. And then we'll have our, at the very end here, our negative 6. So if you remember, we bring down the first value, and that is going to be 1. Negative 2 times 1 is negative 2. 2 plus negative 2 is 0. Negative 2 times 0 is just 0. 0 plus 0 is just 0. Negative 2 times 0 is just 0. Negative 3 plus 0 is negative 3. Let me erase that. Negative 3. Negative 2 times negative 3 is a positive 6. So what is our remainder? 0. And it checks out. Again, if our remainder is 0, then it is a factor. What I want you to do is do both substitution and synthetic division for this problem. You're going to need to know how to do both anyways for your chapter test or your quizzes, so it is good that you utilize this problem to practice both methods. Alrighty, number 4 here. Using a given 0 to write a polynomial as a product of linear factors, real zeros. So part A says, for the polynomial below, negative 3 is a 0. Okay, so let's highlight that because that's important. Let's do it in green. So negative 3 is a 0. Express f of x as a product of linear factors. Okay, so again, we're still within the realm of factor theorem in a way because we are dealing with factors. But this is a little bit of a different problem, so I'm going to kind of write out the steps for you that are going to help you solve this. Again, it's everything you've already done before, whether it's from a previous chapter or even within this chapter, so it shouldn't be too difficult. The first thing we're going to want to do here, so write down step 1, is we're going to divide our f of x by the 0 x minus 3 to factor partially. Again, that word partially is key. Okay. Now that we have that first step, let's just do a synthetic division here. We have this, okay, and we're saying up here at the top that it's negative 3. That means that the original probably expression was x plus 3, but if you take that and you minus it to both sides, you'll get x negative 3, so that's going to be negative 3. And then it gives us all our coefficients here that we need, and they're all in order. That's 1, 9, 11, and negative 21. Remember, you bring down the first term, so that's 1. And then you're going to just multiply everything in the bottom row. So negative 3 times 1 is negative 3. 9 plus negative 3 is 6. 6 times, and let me do this to help if those are confused, 6 times negative 3 is negative 18. 11 plus negative 18 is negative 7. Negative 7 times negative 3 is a positive 21. And so we have a remainder of 0. Again, when we're doing synthetic division, this first exponent is going to drop off, and we're going to technically be starting on this side with x squared. So we have our x squared here. We have our x to the first power. We can claim this as our c, and then our remainder. Now what we want to do for step 2, and I might need a little bit of room here, so let me contract this a little bit. All right, so step 2 here, we're going to title this, and make sure you're putting this in your notes. We're going to rewrite f of x as two factors. And those factors are going to have 0, 0, as well as our quotient. And that's all going to equal 0. So what this is going to look like from what we had in our problem right now is we have our 0 right here, x minus 3. So let's write that down. We have x minus 3. Okay. And then we're going to write in our quotient. As you learned prior in sections of this chapter, our quotient is right here where I'm circling. That is going to be x squared plus 6x minus 7 equals 0. And then step 3, final step, is we're going to factor the quotient. And if you notice, all these steps is something you've already done before. We're just now going to kind of break it out for you and write it out so that hopefully it'll help you to study. So we're going to factor out, again, just our quotient. So let's draw our x over here. Our c is -7. Our b is 6. I want to find two numbers that multiply to give me -7 and add to give me 6. -6. -6. Actually, excuse me. That should be -7. Oops. That should be 7 and -1. That should be 7 and -1. Right? Because 7 times -1 is -7. 7 plus -1 is 6. So my answer here, oops, and another error here. That should be a plus. If you're curious on what I just did, forgive me. That should have been a plus sign right here. Plus sign. So what we have here is x plus 3, x plus 7, and x minus 1. There we go. All right. And that is going to be our answer. Something that might be helpful here is to move this down as well, just so you could see what exactly we were factoring. There we go. And that's going to be our solution. So again, this is something you'd already done before. It's just now breaking out into multiple steps, and we're just going to leave it as that. And I'm sadly leaving out a lot of things here. So this should be set equal to 0. There we go. Okay. All right, there's our solution. Now the right-hand side is going to be the same thing. You don't have to write out 1, 2, and 3, meaning you don't have to write out everything I have written in red. You could just do everything that's in blue here, your synthetic division, and then just go straight into factoring. And then just write down your answer. So again, your answer is going to look something like this that I'm circling. Okay, last problem here. This is a little bit of review. It says, on Alex, the remaining zeros may be irrational numbers, meaning we may need to use quadratic formula. So this is coming up again. I believe this is from chapter 3. So chapter 4 review, the quadratic formula says that if ax squared plus bx plus c equals 0, then, and let's add this in our notes, then we're going to use our quadratic formula, b plus or minus the square root of b squared minus 4ac all over 2a. Again, you've seen that before. That's nothing new. So I'm going to do this problem with you on the left-hand side, and then you're going to do the right-hand side. For the polynomial below, 1 is a 0. Express f of x as a product of linear factors. So we have this down here, and I'm going to utilize synthetic division here. So if it is saying that 1 is a 0, again, 1 is a 0, then we're going to have 1 out here. Then it's 1, -7, 8, and then negative 2. And since the negative 2 is our last one, we can draw our dotted line. As always, the first step is to bring this down. That's a 1. 1 times 1 is 1. Negative 7 plus 1 is negative 6. Again, I'm going fast at this point. We've done this for multiple sections. At this point, we should know how to do it. 1 times negative 6 is negative 6. 8 plus negative 6 is 2. 1 times 2 is 2, so I have a remainder of 0. I need to write out my quotient and my 0. So my 0 was, if it's a positive 1, it should be x plus 1 here. And then my quotient is x squared minus 6x plus 2 equals 0. Let me fix that 0 a little bit. Now, if you tried to factor your quotient, if you did, you would see that you're not able to. So let's put that in here. Not factorable. Not factorable. So because it's not factorable, what we want to use is the quadratic formula. So let's do that. Our quadratic formula, like I have written up top, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We identify our a, b, and c. Our a, b, and c. Let's fill those in. I'll do this part in red. So we have equals a negative, and then remember our b is negative 6, so you have negative 6. And then plus or minus the square root of our b, which was negative 6, squared, minus 4. My a is 1, times my c, which is 2. And that's going to be all over, that's going to be all over 2 times a. So 2 times 1. Let's solve everything under the, or everything in the numerator. So negative, I'm right here, negative 1 times negative 6 gives us 6, plus or minus 6 squared is 36. Negative 4 times 1 is negative 4. Negative 4 times 2 is negative 8. And that's going to be all over 2. And what we get here is 6 plus or minus the square root of 28 all over 2. We want to pull out a perfect square out of 28, or find a perfect square, I think is the better phrase. So 4 times 7, the square root of 4 times 7, all over 2. So what that gives me is 6 plus or minus 2 square root 7, all over 2. We can simplify everything. We have 2 goes into 6 3 times, 2 goes into 2 once, and that just leaves 1. So what we have here is 3 plus or minus square root, make that cleaner for you, 3 plus or minus the square root of 7. What that is 3 plus square root 7, comma 3 minus square root 7. Now, after all that, we have our solution here. So we're going to have our 0, that is x minus 1. Oops. You know, I always want stuff to look clean for you all. X minus 1. And then we're going to have x minus 3 plus the square root of 7. And then we're going to have x minus 3 minus the square root of 7. And that's all going to equal 0. There we go. That's going to be our answer. Again, it seems like it's a lot of work, but again, I broke down each step, or should I say I went step by step. But you have already done synthetic division. You've had a ton of practice on the quadratic formula. And then just, I guess the only maybe new thing would be packaging your answer correctly. Other than that, this is all review. And you're going to want to try to do letter D on your own. With that being said, that is the conclusion of 4.8. Thank you, everyone.